Hey, Dipanjan here. Having a passion for helping people kickstart their own journey in data science, I have worked with diverse companies and universities to help build courses to basically enable people to be job ready by gaining relevant skills in the area of data science. Now, there are several advantages of doing Propulsion's Data Science Immersive Bootcamp. First and foremost, which resonates with my personal motto, is basically Propulsion believes in a live cohort based learning system, which means you have a small focus group of 10 to 20 students who interact in live sessions with instructors who teach them relevant concepts covering a breadth of areas in data science, including understanding statistics, Python fundamentals, linear algebra, databases, machine learning, deep learning, natural language processing, computer vision, and even elements of machine learning engineering like how to deploy models and build end-to-end applications. The instructors are all experts from the industry, where they themselves have been data scientists or data science leads for several years. And Propulsion also brings in guest lecturers from diverse domains in the industry, which gives the students an exposure of how data science is done in the real world. Another interesting aspect is it's not just about learning concepts or the instructors teaching them concepts, but also having live hands-on coding sessions where they actually get to apply the concepts they have learned by working on real-world data sets and interesting applications in data science. Besides this, they also work on exercises to reinforce their learning, and in case they get stuck, they get direct support from teaching assistants as well as the instructors themselves. And I think this is a very important piece of learning, because in traditional online, massive open online course-based formats, typically you have maybe assignments, you may have some live hands-on coding notebooks, but usually it is never live. It's always pre-recorded, and there's literally like no communication between the instructors and the students. So compared to that, I think this is more interactive, and if you are stuck anytime, you can always reach out to the instructors, the teaching assistants, and Propulsion's team with the TAs are definitely very helpful to make sure that the students are actually understanding what they are learning and they don't get stuck at any point of time. Besides this, some of the other interesting aspects of this program is that once you actually reach the end of this program, you get to apply all your learnings in an actual industry capstone project, which is done in collaboration with companies from Propulsion's network. This is very important because I think in a lot of online courses, it just ends with basically you getting a certificate and that's it. You don't get to actually work with the company on a real world problem. And I think this kickstarts your journey in data science in definitely the right direction, with basically having a project in your portfolio which you have done based on a real-world industry project. Other interesting aspects include having access to the Swiss job market, which I think otherwise is very challenging to navigate on your own, having access to Propulsion's wide network of industry-based experts, companies, as well as having a wide variety of things like hiring days and other interesting events, meetups, and so on. Now, having worked with Propulsion for several months now, I can definitely say that the curriculum is state of the art, which is constantly evolving over time, because as you know, the whole field of artificial intelligence, machine learning, and data science itself is ever evolving, with technologies being replaced, new techniques coming in. So we are making sure that this curriculum is evolving over time so that students learn the latest and the best in terms of concepts, methodologies, tools, frameworks, and so on. Python is a programming language which draws in elements from both functional programming as well as object-oriented programming languages, making it a very powerful general-purpose programming language which can be used to solve a wide variety of problems in data science, scientific computing, data analysis, data engineering, as well as build end-to-end applications leveraging principles of software engineering. This is why if you're serious about a career in data science or machine learning engineering, I feel that you should definitely not just learn but also master Python, given its active developer ecosystem constantly pushing out updates and enhancements to the Python programming language, as well as a diverse yet very mature open source ecosystem of libraries and frameworks dedicated towards leveraging data science capabilities in Python. Just like libraries including NumPy, Pandas, scikit-learn, TensorFlow, PyTorch to name a few, using which you can solve complex yet challenging problems across diverse areas like machine learning, deep learning, natural language processing, computer vision. This is why at Propulsion we focus on not just understanding the fundamentals of the Python programming language, but also leverage hands-on examples to understand as well as learn and implement how to write efficient yet simple and elegant Pythonic code, and also master all these dedicated libraries around the data science ecosystem so that you can build your own applications in machine learning and data science. Deep learning is a subfield of machine learning which leverages neural networks to solve increasingly complex problems in areas like computer vision and natural language processing. Popular applications of deep learning include image classification, object detection, object and instance segmentation, image generation, video classification or detection, as well as problems in the area of NLP, just like text classification, text generation, chatbots, information retrieval, search engines, and many more. If you are really interested in getting started with deep learning, I firmly believe you should have a solid grasp on machine learning fundamentals, as well as advanced concepts like how to build your own models, how to tune your models, how to evaluate your models based on a wide variety of evaluation metrics. And then only you should jump into deep learning by starting with the fundamentals of understanding how neural networks are built, including what is a neuron, what is a hidden layer, what are nonlinear activation functions, what is a loss function, how does gradient descent and backpropagation work. And also coupled with the theoretical concepts, you should also try to pick up a language like Python along with a library like TensorFlow or PyTorch and build your own deep learning model, starting with a simple, dense or artificial neural network. Play around with the model, the layers, the activation functions, and then dive into more complex models like convolution neural networks, recurrent neural networks, LSTMs, GRUs, sequence-to-sequence models, and even pick up more complex models like generative models and transformers. Coupled with this knowledge, you should also try to apply these models in different applications, just like segmentation, classification, detection, generation, anomaly detection, and so on. This is why at Propulsion we firmly believe that students should go through a solid understanding of machine learning principles, including not just learning about concepts but applying them in different scenarios like regression, classification, anomaly detection, clustering, and so on. And armed with this knowledge, that is where we dive into the essentials of deep learning, including the various components of a neural network, how does a neural network learn things over time, as well as picking up a library like TensorFlow and building your own neural networks. And we also focus on application-centric problems like object detection, segmentation, image classification, as well as leveraging the latest and best methodologies and libraries, just like transformers, to solve increasingly complex problems in NLP like question answering systems, search engines, and so on. Natural language processing, popularly known as NLP, is an interdisciplinary field drawing in elements from computer science, artificial intelligence, as well as applied linguistics. NLP focuses on trying to make machines learn, understand, and comprehend unstructured text data or audio or speech data to perform increasingly complex tasks. As a data scientist, if you want to differentiate yourself and stand out from other applicants, natural language processing is definitely a skill you should try and master, given that over 80% of data is unstructured in most enterprises today, and they are definitely trying to figure out how to tap into that vast reserve of data to extract additional insights, besides leveraging databases, relational and structured data, by looking at techniques like SQL and so on. To master NLP, you should try and first understand how to load text data, how to process and clean this text data, and then look at elements of representation learning to represent this text data into easy to consume and understand numerical formats, which can be basically understood by machines. Once you process your data in this format, you can then leverage any kind of downstream machine learning or deep learning models based on the problem you're trying to solve. Real-world applications of natural language processing include aspects like text classification, which you can use to find out whether an email is spam or not spam, classifying news articles across different categories of news, grouping similar documents together, finding out important entities from documents like financial or healthcare documents, summarizing as well as finding out the most relevant documents by building search engines or recommendation systems, as well as trying to solve increasingly more complex problems like building chatbots, question answering systems, text generation systems, and so on. At Propulsion, this is why I have worked with them extensively to develop a solid natural language processing curriculum, which focuses on starting with understanding the fundamentals of how to process and load text data, how to clean text data, and then we dive into areas of classical natural language processing, which has been there since several decades now. We look at aspects like how to represent text data using classical NLP methods like bag of words, n-grams, TF-IDF, and so on. And we look at also solving practical applications like classification, clustering, recommendation systems, search engines, and so on. After this, we also dive into deep learning for natural language processing, looking at areas like word embeddings, universal sentence embeddings, as well as diving into the newest area of deep transfer learning for natural language processing by leveraging transformers, which can be used to solve multiple tasks in natural language processing like sentiment analysis, question answering, summarization, building search engines, and so on. So if you're serious about mastering natural language processing, definitely start with the fundamentals of understanding text data, dive into classical natural language processing, and then you can slowly dive into more complex areas of deep learning and deep transfer learning for NLP, including understanding how transformers work and leveraging them to solve a wide variety of diverse problems in different domains. I think being a data science influencer is not just about sharing flashy content or trying to gain more views or likes, but it is about having a genuine passion of sharing your knowledge with the community and also working closely with people to help them kickstart their own journey in data science or dive deeper into their journey in the right direction. And this is where, having worked as a data scientist myself in diverse domains over the last several years, like sales and marketing, supply chain, infrastructure, networking, service management, manufacturing, semiconductors, and even being involved in product development for artificial intelligence-based products, I believe there is a strong need for talented data scientists who can adapt to solving a wide variety of problems, which can even be ambiguous to begin with. And that is where having a wide variety of skills in the form of focusing on the breadth, like machine learning, deep learning, natural language processing, computer vision, as well as the depth, where you learn about the concepts, the fundamentals, the internals of how different models work, how do you tune models, how do you build better models. They are becoming increasingly important skills to have if you want to stand out from other data scientists. And this is where I have always been involved with different universities, organizations, trying to help diverse people to get into the right mindset and the right track to start their journey in data science. And this includes students, working professionals, as well as C-level executives. And myself, being a strong believer in quality over quantity, is where I felt a strong synergy with the talented team at Propulsion, who definitely believe in being laser focused in developing a solid curriculum and delivering it to students but not in a way like, let's say, massive open online courses are developed where you have a huge course with a lot of learners but no interaction going on between the instructors and the students. Propulsion believes in cohort-based learning, which I think is definitely very helpful because we have focused groups of 10 to 15 students with whom live instructors as well as guest instructors come in and they interact with them, have live sessions, teach concepts, have interesting discussions, as well as go over hands-on sessions in the form of understanding how to leverage tools like Python, TensorFlow, scikit-learn, and so on, and solve and tackle real-world problems, and even have exercises and assignments. And at the end of the program, they get to work with folks from the industry and solving real-world problems as a part of their capstone projects. So this is where I definitely felt a strong connection, which kind of resonates with my motto of quality over quantity, and working with people and kind of making an impact to help them start in the right direction and become better data scientists in the future.